So now we're looking at a problem that goes back to why I've been including in all of these triad exercises what the variable cannot equal. And it's because that's where the domain of the function is restricted. It can't equal, the input cannot equal. In this case, x cannot equal whatever makes the denominator 0 because we cannot divide by 0. So to find the domain of a function, it's actually simpler than what we have been doing because we just look at the denominator. We take the denominator and we set it equal to 0. So 4x squared minus 16x minus 20 equals 0. And now the process is the same as what it has been as far as factoring is concerned. 4, 16, and 20 share a common factor of 4. So we factor out the 4. And what we're left with in parentheses is x squared minus 4x minus 5. And now so we have a leading coefficient of 1 inside the parentheses, and it's a quadratic, so we know we're going to have, if it factors, two binomials. We know the leading term is going to be x in both cases, and we want to know what two numbers multiply to negative 5 and add to negative 4. Well, that would be negative 5 and positive 1. So plus 1 and minus 5. Negative 5 and 1 multiply to negative 5, and negative 5 plus 1 is negative 4. And now we use the zero product property. We know 4 is not equal to 0, so I'm not even going to bother with that one. But we know x plus 1 equals 0, or x minus 5 equals 0. And that gives us x equals negative 1, or x equals 5. So this rational function cannot have inputs of x equals negative 1 or x equals 5. So the domain of the function r of x is all real numbers except what we determine makes the denominator 0. So except x equals negative 1 and x equals 5. Or you could say the domain of r of x is all real numbers where x cannot equal negative 1 and x cannot equal 5. Those are equivalent statements.